So we'll talk about failure of distribution boxes in parallel. So failure of distribution box in parallel. So what this is similar to the prior examples. However, we are using continuous distribution function here rather than a discrete. Okay, so similar to the discrete variables, this is the source, and you have a distribution box 1, and you have here is a distribution box 2, and this goes to the destination, and so this is a parallel connection, and distribution box 1 has a life of x1 and distribution box B has a life of x2. What that means is that it will die after a period of x1, and this one it will die after a period of x2. So, and since it is in parallel, the system will work as long as both of them are working. So so obviously we want to know how long the system will work. So let's say Z is the life of the connected system, and we want to know what is the CDF. CDF is just telling me, with CDF you can calculate that at a particular time point what is the probability of that being working. So, and we know that so the x1 has a CDF of f1 t is equal to probability of x1 less than or equal to t, and x2 has a CDF of f2 t, which is the probability of x2 less than or equal to t. Okay, and Z will have a CDF also. Let's say the Z has a CDF of ht, which is equal to a probability of Z less than or equal to t. Okay, but since this is connected as a parallel system, the Z is going to be the max of x1 and x2, because as long as one of them is functioning, it will keep functioning. So probability of Z less than t is the CDF of the connected system. Now, as we said that it's going to be max of Z is max of x1 and x2, so this is just going to be probability of max of x1 x2 less than or equal to t, because that's what Z is. So that will also can be written as probability of x1 less than or equal to t and x2 less than or equal to t, which is nothing but a, and I think this is b. Now since these are this can also be represented just as a intersection b, and since these two are independent events, their probability are just going to be a product of them. So that will be probability of x1 less than equal to 2 multiplied by probability of x2 less than or equal to 2. Now this here is nothing but this, and this here is nothing but this. So this becomes product of f1t times f2t is ht. So we now can calculate the CDF of ht. Now once we calculate the CDF of ht, if we want to calculate the PDF of ht, so how do we calculate the PDF? We calculate the PDF by differentiating it. So all we have to do is differentiate it, that is dH over dt. And now we have to do a rule of differentiation, which is a rule of differentiating product of two functions. Rule of differentiating product of two functions, which is that if we are, what you have to do is you have to do the derivative of first times the second plus derivative of second times the first. So here in this case it's going to become derivative of the first, which is df over df1 over dt times f2 plus df2 over dt times f1. But df1 over dt is just going to be the PDF of f1, and this is going to be the PDF of f2. So the PDF of z or hz, which is the PDF of z, is just going to be f1 f2 plus f1 or f2 f1. PDF of f1, just to clarify this one more time, it is PDF of x1. This is CDF of x2. This is PDF of x2, and this is CDF of x1.